Okay, so we want to do 14, which is sketch f of x is a quarter to the x. Okay? How do we sketch graphs of functions that we don't know?
Figure out what it is.
Okay. We can figure out what it is.
Come up with values for x, and then f of x from that.
Yeah, maybe plot some points and then try to connect the dots or something, right? Okay, so let me plot some points. Here are my 5 favorite points, right? My 5 favorite x values, anyway. All right, which ones of these are really easy?
0, 1, 2.
Yeah, 0, 1, and 2 are pretty easy. What do you get when you plug 0 into this function?
1.
A quarter to the 0 is, don't care, something to the 0, right? So 1. Okay, something to the 1 is
What it is.
whatever it is, so I get a quarter. What do I get when I square a quarter?
1/8. Okay,
No,
I'm sorry.
Thank you, 16. So squaring is not as easy as the other ones, right? Okay, how about the negative 1? What do I do when I've got a quarter to the negative 1? So I've got 1 quarter to the negative 1.
4.
Yeah, flip it over, get 4 over 1, that's 4. All right, how about a quarter to the negative 2?
16, because you negative, so you flip it over and then square it.
Okay, so we could either flip it over first and then square it, or we could square it and then flip it over. Either way. Notice that that should just be 2's point flipped over, right? Or 2's y value flipped over. Okay, so let me graph. Holy cricket. Okay, so let's see. I need, wow, 16. Okay. This is going to be kind of a wobbly picture, right? Because it's going to be kind of super narrow. Let's see, so what's the easy point to put on there?
0, 1.
0, 1. Okay, so there's the point 0, 1 on there.
One quarter.
Okay, 1, 1/4 goes over 1, up just a little bit, right? 2 and 1/16 goes,
1 4 further and then up even less.
yeah, that one's kind of weird to draw in here, right? That's my small picture problem. All right, and then these other guys are
Negative and way up.
back 1 up 4 and back 2 up 16. So back 2 up 16 is here. Back 1 up 4 is there. You guys see this? So if I connect the dots, I'm looking at something that does something like this. You guys see that?
This is a geometric sequence, right?
Ah, so these are geometric sequence, right? With r as a quarter. If I kind of continue this table in both directions, it's kind of a weird version of a geometric sequence, right? Because it's kind of continuing on both sides.
So geometric.
It doesn't have a starting place, right?
Oh, okay.
If I stop and I just look at 0 and positive counting numbers, then it's a geometric sequence with a is 1 and r is a quarter, right?
Right.
If I started here and went to the negative counting numbers, I'd still be looking at r is 1. Now my value gets a bit strange, right? It's really because I kind of collapsed this thing and turned it sideways. Don't worry too much about this. There is a geometric sequence to see in there, though. Cool with this? How do I know it never crosses the x-axis?
Because half of everything isn't 0.
Why are you doing half of anything?
any number of anything that isn't 0 isn't 0.
Yeah, here we're doing quarters of stuff, right? Every one step out on the x-axis takes a quarter of what you just had, right? So if you've got some stuff and 3/4 of it goes away every time period, there's still going to be some left always, right? You guys see that?
Until there isn't.
Yeah, we're not doing quantum chemistry, so stay away from that. Keep in mind, this is math. It's a model of reality. It's not actually reality. Okay? In reality, there's atoms, and those are inconvenient. So we're just not going to talk
It's
about
like
them.
kids building a castle with blocks. In reality, you have to put a lot more weight to deal with.
Yeah. Cool this? So this is what graphs for, this was f of x is a quarter to the x, right? This is in general roughly, right? Roughly. What f of x is ax looks like for a's between 0 and 1. They all look roughly like this. They have different steepness, right? If I was going to do a half, it would maybe look like this. You guys see that? That might be f of x is 1/2 to the x. If I did f of x is 0.9 to the x, that would look a bit more flat, like this. You guys see that? Closer it gets to 0, the steeper this thing gets. Cool?
I mean, more
What's that?
the smaller ones, in which case it's negative, but the smaller the non-absolute.
Yeah.
Since you said
They're between 0 and 1. And when I'm talking about steeper is this piece, right? Really, I'm talking about this line here.
But if you thought about it as you were trying to graph on top of the Earth, on top of the Earth, then eventually it would be steep on both sides regardless.
Fair.